Now that we've introduced the idea of percent change being related to exponential models, let's see how specifically we can take a percent change and use that to represent a model. So if we know that we've got a constant percent change, we're going to write that as r, written as a decimal, not a percent. And we also know that we have an initial value a, so whatever value we start at when x equals 0, then you can actually come up with the equation for that exponential model without touching the calculator. Now, something important to note, if your percent change is positive, then you're going to have a positive value for r. But if your percent change is negative, meaning that your values are decreasing, that would tell you that r is negative, and your values will get smaller over time. So let's try out a problem here. The population of Greenville in the year 2010 was 58,409, and it's grown about 2.24% each year since then. So essentially, they just gave us the percent change. So instead of writing that as a percent, I'll write it as a decimal, so 0.0224. And the initial value, since we're going to use a model that starts in the year 2010, is 58,409. So the equation I can come up with here is a times 1 plus r raised to the x power, where x is the number of years after 2010. Okay, and if you want, you could even rewrite this one step simpler. 1.0224 instead of 1 plus 0.0224. So that model apparently represents the population of Greenville. And in case you're curious, this is the city proper, not the metropolitan area. So we're supposed to use this now to estimate the population in the year 2019. So all I need to do then is figure out what x value corresponds to 2019. Well, that's 9 years after 2010. Let's just go ahead and plug in 9 for x. And that should give me an estimate of the population in the year 2019. So using the calculator, 58,409 times 1.0224 raised to the 9th power. So essentially I got multiplied by 1.0224 9 times in a row, and it ended up with, let's see if I round to the nearest whole person, 71,296. And my units should be people. Okay, so not only is percent change useful to help you decide if an exponential model is a good idea, if you're being told that there is basically a constant percent change, you can come up with the model, and you can use that to predict some values. Okay? Or another way we could use this, if someone gives you a model, you can use it to figure out what the percent change was. If someone showed me this model, I could look and say, oh, that's 1 plus 0.0224. So my constant percent change is 0.0224, or as a percent, 2.24%. So we can either use the percent change to come up with the model, or if we're given the model, we can use the model to figure out what the percent change is. And that can help us describe a lot of different scenarios.